is Sandeep Bhatia, System Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject Microcontroller and Embedded Systems Design, Hemming Code KEC 061, what we have covered, we have completed unit number 1, 2 and 3, and in the 2 lectures back we have started with the unit number 4, and we have seen that unit number 4 is all about the IoT, that is Internet of Things. So, in the previous lectures we have covered the building blocks of IoT, introduction of IoT, how IoT works, what are the typical components of IoT, history of IoT, what are the main technologies that can enable IoT system. We have seen the applications of IoT, we have seen that there are a lot of applications of IoT. So, in this lecture we are going to start the architecture, we will learn the architecture, key challenges and risk in any IoT system. So, in this lecture we will cover these contents. I am taking the ink. So, these are the table of contents we will cover in this lecture. First is the structure of IoT, what should be the structure of IoT, architecture of IoT. Okay. We have seen the building blocks in the previous lecture, but here we will see the architecture and structure of IoT. What are the key challenges facing by any IoT system? What are the current status and future prospect of IoT? Current prospect, future scope of IoT we will see here. Opportunities of IoT and IoT opportunity gap. IoT and home appliances we will see in this lecture. IoT scale and diversity opportunities we will see in this lecture. Top 10 security problems, we are taking top 10 security problems with IoT devices. So, we are covering the contents in these lectures according to your AKTU syllabus. Okay. So, these are the table of contents according to AKTU syllabus. So, let us start with the first topic, that is the structure of IoT. Structure of IoT means how the elements can be deployed in any IoT device. What should be its structure? So, IoT can be viewed as a gigantic network. Gigantic means that large number network, where is the numerous, it is like a word where is the large number of devices are connected with each other. So, consisting of networks of devices and computers connected through a series of intermediate technology, whereas numerous technology like RFID, wireless connection, in the previous lecture we have seen that they may act as enablers of this connectivity. So, basically in IoT large number of objects are connected with each other, there is a network in between them and all are capable to interact with each other, they are deployed, they are smart enough, intelligent enough so that this can be deployed in an IoT based system. So, we are talking about the things. Things means objects, means basically machines which is connected to another machine. So, we will learn more about the things. So, things we can say tagging things, feeling things, shrinking things and thinking things. Tagging means which can be tagged like RFIDs, barcode readers. So, real time item which can be traced and traceability by using the RFID. We can tag the things, we can scan the things, we can tagging is possible. Feeling things which we can feel, how the feeling can be done through the sensors. So, sensors are the primary devices which is deployed in the environment to get the data, to collect the data from the environment. Feeling means they can feel the environment, they can directly interact with the environment. So, the data we are collecting from the environment by using the sensors only. After that, shrinking thing, shrinking means which is very small in size, that is nano scale technology is possible, miniaturization, very small in size, like chips we have talking about, we are reducing the size of a chip from this one to this one. Day by day we are miniaturization is going on, all this through by using the shrinking things, that means shrinking things. So, nanotechnology has provoked the ability of smaller things to interact and connect within the things or smart devices. Shrinking, that is small in size. Thinking means which can be think, which can be realized. So, here embedded intelligence in devices through sensors has formed a network connected to the internet. So, thinking means data analytics can be done. Think which can the devices we are talking about the intelligent means that these are the thinking things. Okay. So, let us start with the architecture of IoT. In this slide we will see the architecture of IoT. Here you can see that in architecture there are 4 layers: application layer, service layer, network layer and device layer. We are going from this one to this one, from the bottom to top. First layer is the device layer, second layer is the network layer, third layer is the service and application layer, and fourth one is the application layer. So, if you can search in Google, you can see books. There are various types of architecture. Some says that it is a 3-layer architecture, some say that it is a 4-layer architecture, some say that it is a 5-layer architecture, some say that it is a 7-layer architecture. All are acceptable. All are acceptable. So, we can say that in 4-layer architecture, 2-layer can be merged, service and application layer. If you can separate these layers, it becomes a 5-layer. Some 1-2 layer are not using here, like transport layer. Okay. So, this is basically you can use any layer model like OSI model, 7-layer, 6-layer, 5-layer, 4-layer, 3-layer. Okay, no issue. So, first is the device layer. This should be there. Device means we are deploying the device, hardware devices. So, in device layer we are using the devices which can communicate with the environment. We are using the gateway. So, devices, we are deploying the devices like sensors, actuators, microcontrollers. So, hardware deployment is there. We are talking about the physical devices. Okay. So, these devices, one device is capable to connect with the another device through the networking. So, networking is there in the network layer. So, in the network layer it has a networking and the transport capabilities. Networking means that all the devices are connected with each other through a network. All this possible in a doing in a network layer. Networking between the devices possible through the network layer. Okay. So, after that there is a service and application layer. We are providing services to the further applications. It has a generic equipment, generic support and specific support. General equipments are there, general service there, some specific task specific service are there, application specific services. So, basically after deploying the devices, networking is done, we are providing service to the application layer. So, in application layer basically we are using our IoT concept in IoT application. We are deploying IoT in a large number of applications like smartphones, smart buildings, smart telemetry, smart homes, smart bridges, smart railways, smart shoes, smart umbrella, smart agriculture, smart irrigation, smart health, many applications. Okay. So, here you can see that smart cities, smart transport, smart buildings, smart energy, smart industry, smart health, smart living, infinity, many more, infinite device applications. So, all the applications are supported by the management capability, journey management we can do, specific management capabilities we can do. Security should be the concern because all the devices are vulnerable to the environment. Security should be the key challenges, and it may be a generic security and a specific security. This is the architecture. So, we will explain more. Device layer means provides a user interface for using IoT. So, different applications for various sensors like transportation, healthcare, agriculture, supply chain, government, retail, etc. all are using the IoT. So, devices and sensors which we can use in our IoT system is GPS, global positioning system. Through global positioning system, we can track the devices, we can calculate the distance between the two we can say that two places. Okay. So, GPS is enabled through the satellite. We are connecting the our devices to the satellite via GPS. Gyroscope which is used in our mobile phones. So, our mobile phone can respond according to our motion, hand motion through the gyroscope sensors. These are the sensors. Accelerometer sensor we are using in our system, Wi-Fi devices, Ethernet, Bluetooth, LoRaWAN, many devices are there. We are not limited to this, many devices. Okay, lot of devices are here. So basically device layer means we are talking about the hardware devices. How the hardware device is made up of microcontrollers, microprocessors, we can say that sensors, actuators, wireless technology that enable devices like wireless devices are there. Okay. So, we are talking about the devices in device layer. Okay. After that there is a network layer. Network means networking between the devices possible through the network layer. So, it is a robust and high performance networking infrastructure. High performance means millions of devices are connected through a network and it should be high performance, and it supports the communication requirement for low latency. Latency should be low. Latency means that throughput, and there should not be delay in the system. The system should respond in the real time. bandwidth should be more and security should be more in any network, because we are going for a network, anyone can hack our system. So security should be there. Allow multiple organizations to share and use the same network independently. So networking, we are doing the network layer, we are doing the networking. When we are going for networking the devices, create a network encryption, we should use encryption techniques, because anyone can decode our data. Okay, you need some encryption techniques so that our device our data cannot be used by any other. Signal processing should be there. Signal processing means we can filter the data, because data we are getting from the environment, it is a raw data, we need to filter it, we need to wave shaping it, we need to amplification here. After that, we have a LT, long term evaluation, we have seen the previous slide. Wi-Fi, SIM module, GSM, microcontroller, embedded, etc. are used in network layer. So basically in network layer, we are going for a network of the devices. How the networking can be done? By using the connectivity devices like wireless networks. Okay, so network layer, we are using the for a network. After that, there is a service layer. Service layer means whatever we have deployed IoT, we are using to for a service. So application service layer, that means the capturing of periodic sensory data. Periodic sensory data, that's data we have gathered through the sensors, we are capturing the data from the environment. After capturing the data, we are doing for data analytics. Data analytics means we can analyze the data that has to be collected from the environment by using the sensors. So we in data analytics, we extract relevant information, we can extract useful information from massive amount of raw data, because the data collected from the sensor, it is a large amount of data, raw data. We can extract our useful relevant information that can be used in our IoT system by using the data analytics. That is the finding of the relevant data, important data. Streaming analytics, streaming means processing real time data. Okay, streaming means streaming can be done only by work in a real time. We can say that live streaming is that real time information provided to the user. So it should be secure and privacy of data, because all the devices are open vulnerable to the environment, anyone can hack them and can use our data. So it should be secure and privacy. So security and privacy is the main concern in service layer, it should be take care while designing any system. Okay. After that, application layer, applications means this is the lower abstraction layer, this is the fourth layer. Okay, we are going from here, device layer, after that we are network layer, service layer, transport layer here, and after that is the application layer. Application layer means whatever we are using our system, it is used for a particular application. So with sensor we are creating the data, getting the data. So these are the physical quantities, interconnect by using the networking, and collect and process the real time information. So after all these things, we are going for a application layer, that is a transportation, healthcare, tracing, people, climatic conditions come under application layer. Okay. So this is the all about the architecture of IoT. After that, what are the various types of key challenges in any IoT system? What are the various types of challenges that has been faced by our currently deployed IoT system? There are various types of challenges. So first is we will see one by one, because there are large number of devices are connected. We are increasing the devices day by day. So we need to ensure its security. So these are the key challenges. First is the always on. Always on means the devices we are using in the environment are always on, like ATM machine, it is always on. It is working on the 24 hours. So devices works on the anytime communication, works on anytime 24 hours, they are providing the data. So it is a chance that it may have a malfunctioning. It is a big challenge we have to take care of. So if you are using the devices that it works on a 24 hours, there is a chance that it may it will affect its functionality. For example, your laptop, if you will not switch off the laptop, it may be possible that your laptop will start hang, will start malfunctioning. Okay. So this is the big challenge, because the devices we are used in IoT are working 24 hours, day by day, day and night, and anywhere, anytime communication. Increased connectivity. Connectivity means connectivity among the devices is increasing. For example, this is the cloud, and we are connecting millions of devices. if we are connected millions of devices, connectivity is increased by day by day. So, this is also an issue. Large number of devices, the devices are increasing, and if the devices are increasing, they are connected to the cloud, connectivity is increasing. So, if the connectivity is increasing, we have to take care of its security. Confidentiality means it is related to the security. All that because each device is connected to the devices. For example, this is device number 1, this is 2, and device number 1 is communicated to the 2. They are providing some data and getting from data here. So, there should be a confidential matter. So, it need to be secure. So, security should be among the devices. Security is the main concern, because all the devices are exposed to the environment, vulnerable to the environment. There is chance that someone hack the data and use our data. So, security should be there, there should be more security. This is the, I think, the main security challenges, main security concern in any IoT system. Regulations should be there. Regulation means protocol and standard, so that IoT devices are made by using these some security regulations and protocols. New demographic means that the IoT we are using in our country, in a foreign, and anywhere globally we are using it. So, in new demographic condition, it should be work, because geographically the environment may vary, environmental condition vary. So, the devices we are used in our IoT based system, it should be capable to withstand in any environment, any demographic conditions, any geographical area. After that, scalability is the main issue. Scalability means up to what extent we are connecting the devices. Here there is a long range communication. So, scalability is the issue, how much scale we can deploy our devices. After that, software complexity, because we are talking about the hardware, but hardware can run through software. So, there is a software complexity, which type of software can be used for which particular hardware, and which hardware is compatible with the which software. So, we are using various types of program software tools in an IoT system. So, software complexity is the main issue. Okay. Data volumes, there are large types of data, because connectivity increases, devices increases. So, the data gathered by the devices also increases. We are going towards the big volumes. Okay. And interpretation. So, we are getting the large number of data, and interpretation is also a big task, because the devices, the data we are getting from the environment has some important information. So, to extract that important information from the massive amount of data, we have to interpret that data, we have to encode that data, also we have to encrypt that data. So, this is the main issue, interpretation. We need many devices to interpret information collected by the system. Power supply, there should be 24 hours power supply to the system. If, for example, in a smart irrigation system, you are using sensors to collect the data, smart irrigation you are doing there. So, these sensors can be activated by using the power supply. You need 24 hours power supply to activate our devices that has been deployed in IoT based system. After that, interaction and short range communication. Interaction means there should not be connection loss in between the devices. Internet should be 24 hours. In rural area, there is issue that internet not work, there is not sufficient towers installed in our rural area. So, this is the issue. So, interaction and short range communication. It is possible that rural areas there is a short range communication. That is the tower which is we have deployed are not capable to send the data to the long range. Short range communication is the big issue. After that, wireless communication, it is the key challenges. Why? Because we are sending the data by using the wireless technology. So, the devices which are used in a wireless technology should be capable and should be work 24 hours and should be able to communicate through a long range. So, wireless communication is a big issue. Fault tolerance means that, what is the meaning of the fault tolerance? Fault tolerance means that I am raising the things here for clear view, just a second. Okay, I am again. So, fault tolerance means that the devices which cannot tolerate fault. For example, ATM machine, you daily life you can see that when you are going for in a ATM machine for to dispense cash, you can some machines say you can see that they out of order. You can, in many cases you can see that ATM machine there is a display out of order. So, out of order means that there is malfunctioning. This ATM machine cannot able to dispense cash, because ATM machines are working 24 hours, um, there may be some malfunctioning there. Okay. So, we cannot tolerate the fault. The machines we are using in IoT system should be capable to work 24 hours, 24 into 7, 365 days in a year, and for many years. Okay. So, fault tolerance means we cannot tolerate fault in any IoT based device. These are the key challenges. Okay, we are facing in our currently IoT system. So, we need to identify the key challenges in IoT system. How the identification can be done? Large amount of chips required, because in IoT means the main concern is that we need a large amount of chips, because the devices are increasing, we need more hardware, more chips. So, this is the also a challenge, more miniaturization, more number of chips, because chips have to become further cheaper and smaller. So, this is the main issue. The chips we are, because we are using large amount of chips in our system, and the key challenge is that these chips should be cheaper and smaller in our system. Big data demand, because we are dealing with the large amount of data, large volume of data, large number of data has to be transportation large amount data in our IoT based system, and this data need to be take care of, because large volume data will be generated by the devices and data center storage. So, we need to store that data. So, big data, we are collecting the big data, and there issue that where to store that big data, because we need more storage system. The data collected from the environment, day by day millions of devices are deployed, they are getting the trillions of data, and these data need to be stored somewhere. So, storage is the big issue, where we can store data, this is the key challenge. Data storage need to be increased. So, according to the data we are getting from the environment, we need to increase our memory storage. Okay, this is the concern. Computational requirement, computation means more computational tasks are there, because the big data are collected from the environment, it need to be computation, more computation is required. Power consumption is more, it should be less, this is the key challenge. Okay. So, power requirement, because the devices need to activate it, it is done through power supply. We need 24 hours power supply. If you are not capable to provide sufficient power to the devices, sometimes it happens that devices are not working. If the devices are not working in IoT system, IoT cannot be deployed, IoT cannot be used. Okay. Standards, all the devices which are using IoT should follow some standards and protocols. So, it should be official standards, it should be globally acceptable by the anyone, and it is used in an environment. So, standards and protocols should be there, so that these protocols can be acceptable by anyone, any company, and IoT based system can be deployed anywhere by using these set of protocols, rules and regulations. Security is the main issue, because we are getting the large amount of data, massive amount of data in getting by the devices, and need to be protected. So, this is the current status and future prospect of IoT. So, here you can see that from 2003 to 2020 to 2022, the number of persons, we are the number of devices increased as compared to number of persons. So, if we are going from the 2003 to 2020, population is increasing, but as compared to population, here you can see that in the 2003 there is a population of 6.3 billion, but it is increased to 6.8 billion in the 2010, and 2020 and 2022 7.6 to 7.8 billion of persons increased, but number of devices are increased far as compared to number of persons, because in IoT number of devices, we are increasing number of devices as compared to person. So, number of devices increased from 500 billion to 12.5 to 25 billion to 50 billion. It is expected that 2022 to 25 70 to 80 billions of devices are connected. So, we need to deal large amount of data, this is the concern. So, here you can see that today we have 300,000 that 3 lakh developers devoted to IoT, and in the 2013 we have 1.3 trillions. It means that the IoT devices we can use in our IoT system are large enough. We need to take care of that data. So, IoT is being enabled by miniaturization is there. In a greater aspect, we can say that miniaturization of the devices, wireless connectivity should be take care of increased data storage. These are the concerns. These are the future prospect of IoT. So, this is the opportunities of IoT. IoT opportunities means that career in IoT. So smart applications we can use, you can use IoT devices in smart farming, smart lighting, machine to machine communication, industrial internet we can use, resource management we can use IoT, portable and wearable electronics we can use IoT, fitness healthcare we can IoT, safer automatic we can use IoT. We are not limited to this only. We are not limited to this only. There are lot of applications, numerous applications, infinite applications and opportunities of IoT. So this is the IoT opportunity gap. Here you can see that it reaches to the millions of people. It is if we are increasing the time, number of things are increasing as compared to population. And today we can see that number of devices are increasing, and the IoT opportunity is much larger than analytics prediction for connected devices. So 30 billions, 20 billions. So devices are increasing day by day, and we can see that connected things are greater than the world population. If world population is right now 7.8 billions, approx we can say, the number of connected devices is around 70 billions. So it is large enough as compared to devices. So things are greater than persons. Okay. So IoT and Hope appliances, here you can see that in Hope appliances 15 billions of devices are connected. For example, let us say if there are couple, it has 2 children, 4 persons are there. So for every 4 persons there are 10 connected devices. It was expected, it was forecast in the year of 2012. So no number of devices compared to. So this is the IoT scale and diversity. Here you can see the large volume of data. As we are increasing the devices, large number of devices, volume increase, set of large 26 billion installed units by 2020. Large number of devices are increasing day by day. So these are the top 10 security problems. In our last slide we will see insecure web interface. Security should be the main concern. This is the security problems. Insufficient authentication. Someone can use our authenticate data. Insecure network services because large number of network required. Lack of transport encryption. The data we are using need to encrypt in our IoT based system. Privacy concern. Someone can hack our data. Insecure cloud service because in cloud there is many data. So it should be need to be secure. Insecure mobile interface. Okay. Insufficient security configurability because unique identification should be provided to the device. Insecure software because software should be secure. Poor physical security. These are the 10 security problems which is IoT devices are facing nowadays. We need to take care of that. So thank you everyone for your patience. I hope you have enjoyed my lecture. In upcoming lectures we will see more about the IoT. Okay, thank you everyone.